this is really what we're going to be doing here is A2, A3, and A4. All signs. So the idea is if I give you guys this with maybe A equals 3 and this angle equals 50 degrees, you can jump right in and solve this triangle. We know how to solve this. Let's call this B and C, and we'll call this big A. Right, we can solve for the missing information here. We just did this. Now, unfortunately, the world doesn't always give us right triangles. So what we would like to do is be able to do the exact same thing, but for oblique triangles. So an oblique triangle is any triangle that's not a right triangle. Oblique triangles. So oblique triangles are not right triangles. Here's your sort of schematic now. And there's kind of the standard labeling that I told you about last time usually applies here. So if I label my angles A, B, C, to keep things easy, I want to label my opposite side lengths little a, little b, little c. So what's going to happen in this section is you're going to be given 3 pieces of information, right? Any 3. Like I could give you this, and this, and this. And then you're going to have to solve for the other 3 pieces of information in this oblique triangle, this non-right triangle. And to do this, you need to use new formulas. Law of sines, law of cosines. Now, there's really 4, I wrote them down here, there's really 4 cases that you can run into with the law of sines and law of cosines. So I'll outline what these are, and that's as far as we go. I'll have to show you the law of sines on Wednesday. But there's four situations you can run into. Okay? Angle, side, angle. Side, side, angle. Side, angle, side. And side, side, side. So what this means, okay, there's kind of a method to this madness. The fact that the S is in between the 2 A's means that you've been given an angle, and the included side. Angle, angle, and included side. So something like, in this triangle you've been given an angle, and the included side. See how this side's between those 2 angles? It's a different case if I give you this side. In this case, you have to use the law of sines. You cannot use the law of cosines. And there will always only be one answer, one possible triangle. So you'll get one set of information that solves this triangle. Side-side angle is the other situation where you have to use the law of sines. And what do you think this means, side-side angle?
Yeah, two sides and an angle between.
Two sides in the excluded angle, so meaning side, side, but not this angle, right? Because this angle would be included between the two. So not the included angle, but maybe this angle up here. And what happens here is, depending on the information you're given, you can actually get multiple triangles. This is what's called the ambiguous case. Because you don't know how many triangles you get until you start actually doing the work. So what I mean is, let me take 1 second and show you the difference here. In this case, no matter which angle, no matter which two angles I give you, and which side length I give you, if I only gave you this angle, and this side length, there's only one triangle you can make with this information. Right? You go out here, you go out here, and that's the only triangle you can make. There's no choice. But in this case, if I give you an angle, let me do it like this. Here's an angle that you're given. You're given this. Here's a side length. So you're given an angle, and you're given a side, and you're given another side. So you have to be given this side over here again. In this case, I can't form a triangle because my side length isn't great enough. No matter how I rotate this, no matter what my angle is here, no matter where I put this side length, if I rotate it up here or over here, I will never intersect the bottom side. Whereas if I draw it like this, side, side, this angle here, then I can form one triangle exactly. And if I make the side length a little bit bigger like this, where this side is like this, and then I can go down here perhaps, or over here. So in this case, the given would be the angle, this side, and then you see in both of these cases, whether I choose this side length or the exact same side length, but in a different position, I can make triangles. I can make this fit. Right, so here would be one triangle, or here would be the other triangle. So side-side angle is the ambiguous case because it's possible to get either 1, 0, or 2 triangles. The other two cases are law of cosines. Okay? Side angle, side, and side, side, side. And there's no ambiguity. You get exactly one triangle. Okay, so what I'll do is I'll start in with these two on Wednesday, and we'll actually use the law of sines to solve the problem.